Now that we know how to distinguish ionic and covalent compounds, we want to learn the rules for each type, and we'll go ahead and start with ionic compounds. So when it comes to naming ionic compounds, the basic idea is that you put the name of the cation first and the name of the anion second. So that's why I remember we talked about naming ions. So it's going to be the process of pulling out what the ions are and just writing them down. One of the things we note is that the subscripts don't come in at all. So for example, LiBr is lithium bromide. The fact that we have lithium is the lithium, right? It's a cation, so we don't change the name, we just keep it as lithium. And then Br is bromide, and we do change that ending "ide" because it's an anion. When we now move to calcium, stays calcium, the cation keeps its name, and then we have the F, the fluorine, but because it's an anion again, it becomes fluoride. And so we can see we just take those names, but there's no indication in the name calcium fluoride as to how many fluorine atoms are present. We just say calcium fluoride. The idea on this is that we don't need to, right? Because if you remember, calcium and fluoride are both fixed charge ions. Okay, so we can use the periodic table to predict what the charge of those is going to be. So if you say calcium fluoride, you can know it's ionic because calcium's a metal. So you know this thing is ionic. Then when you're told it's calcium, you can look at the periodic table, figure out what its charge is. Look up fluorine on the periodic table, figure out what its charge is, use the crossover method, all the stuff we talked about previously as to how you come up with the name, or come up with the formula from this name. So when it's the idea of systematic name, in determining the formula of an ionic compound, all you need to know are the ions involved. And then you can use a crossover method like we did previously to come up with the formula. When you have those variable charge metals, you remember the Roman numerals needed to come into the name of the ion. So when those variable charge ions are in a compound, those Roman numerals stick around. So for example, CuO is copper 2 oxide because this is our copper 2. And then the O is the oxide. Okay, so similar then, this is copper 1, and then the O is still the oxide. Okay. So when we have the name, if we want to turn it into the formula, we just write out the ions, and then we use the crossover method. So if I have copper 2 oxide, I know that's going to be the copper 2 plus oxide. I would have to use the periodic table to know that's going to be O2 minus, and then I can go ahead and do the crossover method, do any sort of cancellation or simplification, and get everything situated. So let's look at some examples. What is the name of each of the following compounds? I have K2S, NH4Cl, and FeO. When I'm going through this process for ionic compounds, I'm going to write out the name of the cation, followed by the name of the anion. Okay. So you were told that these are ionic. Normally, you would need to figure out that you're dealing with something that's ionic, but in this case, you were told. So it's just the cation and the anion. But we could still figure out that these are ionic based on metals or the presence of NH4. So K2S, is this going to be a matter of, really, we can just look up that, if we're using the periodic table, K is potassium. And then we also know that S is sulfide or sulfur, but because it's an anion, you need to change that ending to the IDE, so potassium sulfide. We don't need to have any information about the two because the fact that it's potassium and sulfide, we could figure out what the charges are, and from that determine what the formula is and all that kind of stuff. For NH4Cl, we want to be careful. This is NH4. That is ammonium, right? That is an entire polyatomic ion. Whenever we start off with NH4, we want to be mindful that that is a polyatomic ion that's going to be ammonium. The Cl is then the chloride that is left over. FeO. On face, we may be tempted to call this iron oxide. Fe is iron, O is oxide. But Fe is a transition metal. Since Fe is a transition metal, we don't know what charge cation it's going to form. We have those handful of exceptions, but in general, if you have, a transition metal, you can't know what the charge is going to be. So we need to figure out, in order to name this, we know it's going to be iron something oxide with a number. We need to figure out what that number is going to be. And we're going to use two facts. First, we use the fact that oxygen is -2. When it forms an anion, we know anions are always fixed charge, so oxygen is always -2. We also know that the overall compound has to be neutral. Cation plus anion has to add up. All your charges have to add up to 0. So what we can do is we can say the overall charge of 0 has to be equal to the charge of the iron atom plus the -2, which is the charge of this oxygen, right? So we have one Fe, we have one oxygen. When we add their charges together, they have to be 0, which means that the charge on this iron has to be opposite the charge on the oxygen. If you had more than one of an atom, you could use coefficients, right? You'd have 2 irons or something like that. But in this case, the charge on the iron is going to be +2, which means we would call this iron 2 oxide. Okay, we know that this compound is iron 2 oxide. We could have, say, iron 3 oxide. That would have a different formula. Iron, whatever, if we change it up. You could have different formulas for those different size cations.
Participation 6.5, question 4. Name the following ionic compounds. A, Na3N, B, CaClO3 2, C, Cu2S, and D, Cus. This is the fourth question on participation 6.5, due Friday, June 5th at 11:59 p.m. over on Blackboard. Link to the assignment is right below the links to these videos. Again, name the following ionic compounds: Na3N, CaClO3 2, Cu2S, and Cus. Okay, another participation question. We're really stacking them up here. A couple more videos to go. Looking for any more of those participation questions. See you in the next video.